Okay, so what I want to do right now is I want to go over quiz number 30. This is quiz 30B, so this is for my B-Day students. I want to go over this quiz because I know it was a rough one, and I probably won't have time to go over it in class, and so maybe this video can give you some assistance in dealing with maximums and minimums, extreme values of functions. Okay, so the first question here, it said to identify the x values of all absolute maximum and absolute minimum points. And you were given this graph and you were told that this function is f of x. That is the graph of f of x. So f of x, now we're looking at this, we have an open circle at a, which means that a is not included on the interval. And we have a closed circle at b, which means that b is included on the interval. And then the second part of the question says, state whether or not the extreme value theorem can be applied and explain why. Well, in this particular case, the extreme value theorem cannot be applied because this is not a closed interval from a to b. The extreme value theorem states that if a function is continuous, which this is, on the closed interval from a to b. Okay, but this is an open interval on the a side, and therefore the extreme value theorem cannot be applied. And what you would say, it says, explain why. Because it is not, the interval is not a closed interval. That's why the extreme value theorem cannot be applied. But now let's look to see if there's an absolute maximum and an absolute minimum. Well, the lowest point here is right here at C1, so we would say that we have an absolute minimum at x equals C sub 1. Now, the absolute maximum, the highest point, would be up here at a, except that it is an open interval. Therefore, a is not included, so there is no absolute maximum. No absolute maximum at all. Okay? So that's the first part right there. You were not asked to identify relative maximums and minimums on that problem. All right, now let's look at the second graphical one there. And let's see, we had a closed circle here at A, which is down here, and then it sort of curved up like this, and then it was kind of straight and over to a closed circle at B here. Okay? So now the question is, does the extreme value theorem apply? Well, even though this is not differentiable, and that's let's see, that's C sub 1. Differentiability is not required. It's not necessary for the extreme value theorem. We just need continuity. And it is continuous, and it is continuous on a closed interval from A to B, so the extreme value theorem can be applied. It guarantees that there is an absolute maximum and an absolute minimum. And so where is the absolute maximum? Well, it's right there. That's the highest point. The absolute maximum is where x is equal to C sub 1. And where's the absolute minimum? Well, the lowest point, this is not the lowest point. None of these points are the lowest points. The lowest point is over here at A. So we have an absolute, it's at the end point. The absolute minimum is where x is equal to A. And so there is that's the first part. Those are the graphs at the top. Now let's talk about the next one here. The next one says that it says for each of the following, identify the coordinates of all absolute maximum and minimum points, and then state whether or not the extreme value theorem can be applied and explain why. Well, the first one says f of x is equal to negative x cubed plus 15x squared minus 63x plus 60, and it says on the closed interval 2 to 8. 2 to 8. Okay? Well, this is a polynomial. All polynomials are continuous and differentiable from negative infinity to positive infinity. We're looking for the extreme maximum minimum on a closed interval from 2 to 8. So it's a closed interval, it's continuous, therefore the extreme value theorem can be applied, and it guarantees that we will have an absolute maximum and an absolute minimum. Let's find out what they are. We've got to identify the derivative. critical points and endpoints, critical points and endpoints. That's what we're looking for. Always looking for critical points and endpoints to find where our maximums and minimums are. So the derivative here is going to be negative 3x squared plus 30x minus 63. And right away I can see that there is a greatest common factor of 3 in all of this. But I'm not just going to take 3 out. I'm actually going to take negative 3 out. Never really talked about this. I don't know how many people do talk about it. Oftentimes it is better to have the lead coefficient of a polynomial as a positive value, which means if you're factoring something out of a polynomial and your lead coefficient is negative, go ahead and factor out a negative value, not a positive value. Don't leave that negative behind. Take it out with the 3. That way, when you factor it out, your x squared is a positive x squared. I'm not saying you have to do that. I'm just saying that sometimes it's very helpful. If I factor out a negative 3, I get negative 3 times the quantity x squared minus 10x plus 21. Well, this is, without having a negative here, it certainly is going to make this a lot easier to factor if it can be factored. And if I'm looking for two values that multiply to positive 21 and add up to negative 10, I'm thinking negative 3 and negative 7. So this is actually negative 3 times x minus 3 times x minus 7. And if I set this equal to 0 to find my critical points, I can see now that I have one critical point at 3 and another critical point at 7. Both of which are on the interval from 2 to 8. I don't have any points where it's not differentiable, so I can now start to create my table. I can have my x values and my f of x values to identify my maximums and minimums. I've got an endpoint at 2, I've got a 3 critical point, I got a critical point at 7, and I've got an endpoint at 8. And when I plug each of these into this, now you had to use kind of a crummy, one of those crummy little, when I say crummy, I like them. They're 4-function calculators. Some of you were using scientific calculators because I didn't have enough of the 4-function calculators. I don't have a 4-function calculator handy right now, but I do have this scientific calculator. So let's see. If I'm going up here, I'm going to go negative. Let's see, x to the third plus 15 x squared minus 63x plus 60. And so I'm going to plug 2 in, and I get negative 14. Okay, I'm going to plug 3 in, and I get negative 21. I'm going to plug 7 in, and I'm going to get 11. And I'm going to plug 8 in, and I'm going to get 4. Okay, so once I have the output values, it's very clear. This is the lowest value. Therefore, that makes this the absolute minimum, and the highest value is here at 7, so that is the absolute maximum, and that is all that this asks. It said to identify the coordinates. So absolute max at 7, 11, absolute minimum at 3, and negative 21. And that is the first one. All right, let's look at the next one now, g of x. Okay. Let's see here. All right, g of x is x cubed over 3. G of x equals x cubed over 3 minus x squared minus 8x plus 7 on the interval 0 to 6. Closed interval 0 to 6. Well, again, we've got a polynomial. We're on a closed interval. This is continuous everywhere. This is a closed interval, so the extreme value theorem does apply. And you would want to state because it's continuous on the interval, on the closed interval from 0 to 6. So we can guarantee an absolute maximum and an absolute minimum. Our endpoints are 0 and 6, so we'll test those in a minute. But right now we need to find critical points, so we need the derivative g prime of x. If we do the derivative here, this can be x squared minus 2x minus 8. And this we can factor into, let's see, two numbers that multiply to negative 8 and add up to negative 2. That's going to be x minus 4 and x plus 2. And we set that equal to 0, and we get critical points at x equals 4 and x equals negative 2. Now, of course, negative 2 is not on this interval. Negative 2 is not on this interval. Negative 2 is not on the interval from 0 to 6, and therefore it is irrelevant. We're not even going to test that critical point because it's not on the interval. We only care about 4. We only care about the critical points that are internal points on the interval we're looking at. So we're only going to deal with 0, 4, and 6. 0, 4, and 6. Okay, and then we got g of x. So we're going to plug these numbers into the original function. Well, 0 is easy. When we plug 0 in, we get positive 7. Let's see, when we plug 6 in, we'll do 6 to the third power, which is 216, divided by 3 is 72. And then minus 36 minus 48 plus 7 is negative 5. And then here, this one's going to be sort of a mess. 4 cubed is going to be 64 over 3. So 64, I probably have to write this one down. 64 over 3 minus 4 squared is 16. Okay, but if I convert that 16 times 3, that's 48 over 3. To make it easier if I convert it to a fraction. Minus 8 times 4 is 32. But 32 times 3 is 96. So now it's minus 96 over 3. Plus, instead of 7, I'll do 21 over 3. See, what I'm doing is, because this one was over 3, I'm turning them all into over 3. So now I can do 64 minus 48 minus 96 plus 21 is negative 59 over 3. Negative 59 over 3 is what I have there. And negative 59 over 3 is clearly smaller than negative 5, because negative 5 would be negative 15 over 3, and this is a larger magnitude. So that right there, that is my absolute minimum. My absolute maximum winds up being at my endpoint, 0, 7. My absolute maximum is at 0 and 7. And then this is at 4 and negative 59 over 3. Now, if you did negative 59 divided by 3 and you got negative 19.6666, that's okay too. I would take that. But that's the absolute minimum. And that was all that was asked for in that problem. So there's the absolute maximum, the absolute minimum. So if you didn't get those right, I would try them again and maybe do them 3 or 4 times. I know that sounds crazy, but sometimes doing the same problem 3 or 4 times can really exercise your ability to do a skill, to be able to, especially with identifying minimums and maximums. All right, now let's go on to the crazy ones, the ones that you probably didn't like very much. It says, identify the coordinates of all relative minima, relative maxima, absolute minima, and absolute maxima of f of x equals e. See, f of x equals e to the cosine of x on the interval from 0 to 2 pi. 0 to pi. So of course we'll check our endpoints, but we need the derivative of this to identify any critical points. So f prime of x, this is a chain rule problem. We're going to do the derivative of the inside, which is negative sine of x, okay, times the derivative of the outside, which is e to the inside unchanged cosine of x. So there's your derivative. And we want to set this equal to 0. Well, there's something you need to consider here, and that's the fact that e to the cosine of x can never equal 0. Okay, e unless it has a y shift on the end, like -7 or -1 or something like that, e will never equal 0. So this will never equal 0. That means that if the derivative is going to equal 0 at all, it's going to be because of negative sine of x. Therefore, and because negative sine of x does equal 0 sometimes, we are only going to check for where negative sine of x is equal to 0. So if we set negative sine of x equal to 0, and now if we think about on the interval from 0 to 2 pi, well, sine equals 0. Between 0 and 2 pi, it actually equals 0 at 0, because negative sine of 0 equals 0. It also equals 0, negative sine at pi equals 0, and sine also equals 0 at 2 pi. So we're actually checking the endpoints. We're noticing that the endpoints are coming up as critical points as well as endpoints, which is irrelevant because we're going to test them anyways. But what you're now seeing is, aside from the endpoints, we also have to check out pi. Okay? So that's a critical point, that's an endpoint, that's an endpoint, or you can call them all critical points, I don't care. The fact of the matter is we have 3 candidates to check. 3 candidates where we're going to have zeros. So now, if we have x and f of x, we're going to test 0, we're going to test pi, and we're going to test 2 pi. These are all the places where we could potentially have an absolute maximum or an absolute minimum. I'm going to erase this right here because I need room next to that. You can just rewind the video if you want to see that again. Okay, so now I'm going to plug 0 into the original function. If I plug 0 into this, what's cosine of 0? Well, cosine of 0 is 1, and e to the first power is just e. So that's e. By the way, 2 pi, if I plug 2 pi in, cosine of 2 pi is also 1. So e to the first power, that's also e. Okay? And lastly, we're going to plug in pi. Cosine of pi is -1. So that means e to the -1. Well, that's you can either say e to the -1, that's one way to say it, or if you like, you could also say it as 1 over e. They're both the same. Okay? Both are equally acceptable. Now, 1 over e is approximately 2.7 something. Let me confirm that. Let's see what the scientific calculator says. E is, 2.718281828, okay? So about 2.7, let's say for now. Well, 1 divided by 2.7, if 2.7 is larger than 1, then this value right here is going to be less than 1. And e is approximately 2.7. Well, that means that both of these values are larger than this value, which makes this the absolute minimum. Okay? These two values are the same and larger, which actually means that the absolute maximum is occurring at 2 places. So the absolute minimum is at pi and 1 over e, and then the absolute maximum, okay, is occurring. Now, if you gave me 1, I'm okay with that. You should identify both, but if you gave me just one of them, I'll give you your points, okay? The absolute maximum, there's an absolute maximum at 0e, and there's also an absolute maximum at 2 pi and e, and that is the end of that problem, okay? Last one, identify the coordinates of all relative minima, relative maxima, absolute minima, absolute maxima of g of x. And g of x is kind of a doozy here. You probably felt that way too. We got sine of the natural log of x. G of x is equal to sine of the natural log of x. And it's on the closed interval, open interval. It says on the open interval 1 to e to the 2 pi power. Okay? All right, so it's actually the open interval 1 to e to the 2 pi power. Okay? All right, now, what this means is this. Because this is an open interval, it means that we are not going to check the endpoints. And I know that that may be coming as a surprise to several of you, maybe, that you lost some points and you're not sure why. That could be the reason that you lost some points, because the question states to identify relative minima, relative maxima, absolute maxima of g of x for the open interval. So we cannot have maximums and minimums at the endpoints now, because there are no endpoints. It is an open interval. Watch your symbols, okay? Okay, so the only place we're going to have maximums and minimums is at the is wherever the critical values are. So let's identify the critical points, g prime of x. Okay, so this is a chain rule problem. We're going to do the derivative of the inside, which is 1 over x, times the derivative of the outside, which is cosine, and then the inside unchanged, natural log of x. Okay, there's our derivative. Now, like the last problem, you might notice here that 1 over x cannot equal 0. And because it cannot equal 0, it cannot be a part of, or it cannot cause the whole thing to equal 0. The only way this is going to equal 0 is if cosine of natural log of x equals 0. So cosine of natural log of x equals 0. That is going to identify our critical points. So the question here is this: what could potentially cause the natural log of x, what could cause cosine to equal 0? Well, cosine will equal 0, now on the interval from 1 to e to the 2 pi power. Now e to the 2 pi power is, let's see, 2 pi is about 6, e to the 6th power is like 2 to the 6th power. So that's like in the 60s and 70s maybe, okay? So that's a pretty big number, all right? And cosine is going to equal 0 at pi over 2 and pi over, let's see here, pi over 2, 3 pi over 2, and at any values in pi's, so it's also going to be 5 pi over 2, it's going to equal it at 7 pi over 2, etc. Okay? So, cosine equals 0 at any one of these values, so we want to find out whenever the natural log of x is going to equal pi over 2, or the natural log of x is going to equal to 3 pi over 2, or anything like that. Okay? And so, when is that going to happen? Well, look at this. Natural log of x is the same thing as log base e of, well, actually, let me do it a different way. If we want to set x free here, we have to do e to the natural log of x. Okay? And if we do e to the natural log of x, we have to do e to the pi over 2 power. Okay? And this is going to cancel the natural log because e and natural log are inverses. And now what we're going to see is that x is equal to e to the pi over 2 power. So, cosine of the natural log, and this is going to sound kind of crazy, cosine of the natural log of e to the pi over 2 power is going to be the same thing as cosine of pi over 2, which is going to be equal to 0. Okay? And so what's going to happen here is we are going to have, our derivative is going to equal 0 at e to the power of pi over 2. It's going to also equal 0 at x equals e to the power of 3 pi over 2. Okay? And then it would be x equals e to the 5 pi over 2, except notice something. E to the 5 pi over 2 is larger than e to the 2 pi power. Okay? So this is outside of the domain. In fact, all of the things that would make cosine equal 0, above 3 pi over 2, they're out of the domain. And what we have now is these are the only critical points. We don't have endpoints. These are the only critical points, which means these are the only candidates, the only test values for the maximum and minimum. So now x, g of x, if we plug in e to the pi over 2 and then plug in e to the 3 pi over 2, here's what's going to happen. If we plug in e to the pi over 2 in here, we're going to have sine of the natural log of e to the pi over 2. Okay? Well, the natural log of e to the pi over 2, that equals pi over 2, because the natural log and the e cancel each other, and all we have left is pi over 2, and sine of pi over 2 equals 1. So this is 1. Now we're going to do sine of the natural log of e to the 3 pi over 2. Natural log and e cancel, and we now have sine of 3 pi over 2, which is negative 1, and these are our maximums and minimums. Okay? Now, here's the thing. We actually don't know if they're absolute maximums or absolute minimums or relative maximums or relative minimums, because these points right here could potentially be higher points. Now, knowing that sine can only go as high as 1 and only as low as negative 1, I know that they are the absolute maximum and absolute minimum. But if you didn't know that already about a function, then you would have to plug in these, they're not endpoints, but the things that would be at the endpoints to find out if they're larger or smaller. If you did plug 1 in here, natural log of 1 is 0 and sine of 0 is 0. If you were to plug e to the 2 pi in, natural log of e to the 2 pi, natural log and the e cancel, and you have 2 pi, and sine of 2 pi is also 0, so it's irrelevant. Those are in the middle, and this is what we have. Our absolute minimum is at e to the 3 pi over 2 power, comma, negative 1. That's one coordinate. And then the absolute maximum is at e to the pi over 2 and 1. And that is, I know that's the last question. And I know it was terrible. Okay? I really want to give you guys a chance to be challenged and improve your mathematical ability. Okay? And like I said, I'm probably going to, when I give you a retake for this, I'm probably going to give you a retake that's a full retake so that you can get those points back. But I hope you got something out of this video, and I hope that you have a better understanding of the trig functions, natural log, and e as well. Okay? All right, thanks a lot, guys.